Hey there YouTube, this is sjm4306 back with another video. This time it's another project video, obviously sponsored by JLC-PCB. A word from this video sponsor. Got an idea for a circuit, widget, or device that you want to rapid prototype or sell? Check out JLC-PCB. They offer their board manufacturing services starting at $2 for 5 boards and only take a few days from start to finish. So make sure to check out JLC-PCB. And once again, thanks for making this video possible. Now let's get on with the video. I've been up to my shenanigans again, and sorry if you can hear a fan sound going. It's like super hot and humid right now, and I'm gonna pass out if there's no fan on. So anyway, I ordered some goodies, and this time, actually these two boards, which are actually identical, and what these are going to be, here I have one out to the side right now. Basically, I've been doing a lot of Arduino projects, well, clearly, using the IDE, but not necessarily the libraries. But anyway, the point is I needed something bigger than the standard Arduino, which is the Atmega2560. And with that, you're limited to, 32K of flash, 2K of RAM, and something like 20-ish I/O. So I wanted something bigger, and I've known about the Arduino Mega for quite a while. I just never really got into it, and basically bumps everything up like crazily. I think this has like 256K of flash, much more RAM, has 50 some I/O pins, and just overall it's pretty much better in every way, with the exception of the clock is still only 60 megahertz. But anyway, I wanted to give a play around with one of these boards. Now, official ones are like $50 or something like that, and they do sell clones, and this is actually what inspired me. The very small kind of development clones that they sell are about this size. This is actually a little smaller than them, and that sort of inspired me to make my own. Just for the process of designing the board, practicing, and also I had recently got this little guy, which is a tiny little hot plate. So what I thought I'd do is my first foray into solder stenciling application as well as reflowing, because I normally do all these videos by hand, soldering it manually, but JLC-PCB does have an option to provide you these really nice stencils. I think this stencil itself cost me about, I think it was only like $7 or $8. It was definitely less than $10, and that was with the added feature. They did some kind of electro polishing to make the edges smoother so that solder paste won't stick as easily to the stencil. So I opted for that, and it's still only $7, so why not? And so the idea is, if I do this process using Reflow, it's going to take a lot less time. I would estimate to do this by hand would take about an hour. Given I've actually assembled one of these just for practice to get the run so I can get it through without any major problems. So I'll be a little quicker this time probably, but I'm expecting I'm still going to have some issues just because my technique isn't so great. Anyway, I'm gonna get everything set up, and we are going to run through how to solder stencil, and this will be my second time practicing. Okay, so I'm all set up. I just used a bunch of this blue painter's tape. I taped 3 of the boards on just so that I can create kind of a brace that my board can slide right into. I just use the same board. Any other board of the same thickness will work just fine. And so that I can just wedge the board in, and then I very carefully aligned the stencil on top while looking straight down onto it, and make sure that everything is aligned. It can be slightly off, but especially for this TQFP, the quad flat pack, the pitch is pretty darn small on that. So you want to get that as best as you possibly can. Otherwise, what's going to happen is you're going to get likely bridges in between the pins when the solder paste actually flows. Anyway, this looks pretty good, so let's actually get set up for applying solder paste on. Okay, so I am set up here, and I have the board that I'm going to be stenciling. Make sure the orientation is correct first off. So basically the crystal on the top side, the USB port on the bottom. It's really hard to get a clear shot of this because I have really bright overhead lights, and this is stainless steel, the stencil, so it's highly reflective. Anyway, I have it boxed in, and I'm just going to push it in there, push it down, and double check the alignment. And it looks like I'm off just a smidge, so I'm actually going to reposition. That looks pretty good. So next step is the fun part. Not the funnest part, but a fun part. I have this random craft squeegee thing. I think it's for applying vinyl, but pretty much any credit card or anything like that should work. I have this little jar of Chip Quick, and here we go. You can hopefully, there you go. The model number is there. This is actually, I didn't know this existed. This is thermally stable solder paste. Normally solder paste you have to keep in a refrigerator, and it doesn't last very long even then. But this is rated to last a year at room temperature. And you can see here it is actually leaded solder, so none of that lead-free BS. Anyway, I'm just gonna kind of grab a bit and slop it down on there. It'll help if I get a toothpick, grab a blob of it. Now, it's not that we're gonna need all this, and I'm not gonna waste all this. Anything that's unused, I'm just gonna scrape off and put right back in this tub. So don't worry about using too much. It's probably worse to use too little. And this is a little messy, so I would keep some tissues or something nearby. And keep the solder paste closed just so it doesn't dry out when you're not using it. Okay, we're going to try to scrape evenly. Now, the pros will do it in one swipe. I'm not a pro, so it's going to take me a couple. But important thing is keep firm downwards pressure on the stencil so it doesn't lift. Okay, and important thing is making sure the stencil does not move. And that looks pretty good, so I'm going to lift it and inspect. It looks like maybe my stencil is off just a little bit, but I'm just going to carry on. The process isn't perfect, but should be good enough. Any extra solder in between should kind of, due to surface tension of the solder when it heats up, should kind of find its way to the right pad. The issue I had before was actually I had some bridging on here, so we're going to see if the same thing happens. If alignment, maybe I need to be more careful aligning everything. But if it does, that's easy enough, just with some solder braid taking care of that. But anyway, I'm just going to proceed as planned with this. It's not perfect, but, this is only my second board. So let me get this cleaned up first off. Okay, the next part, I have all the parts just laying in this little container here ready to go. We're actually going to pick up each part and place it on the pads, get it roughly aligned as best as we can. And this I'm going to speed through. This might take a little while. It's probably best idea to do this you know, if without taking any caffeine or anything like that. I did have a cup of coffee a couple hours ago, so my hands may or may not be the steadiest, but I'm gonna try to give this a good shot. Okay, and the paste sorta acts like a glue a little bit. Well, acts like a paste, so the parts aren't gonna fly off just on their own, just while you're handling it. But still, just be careful and only touch the board by the edges. I think I got everything placed, so we're just gonna fire up the hot plate and give this a reflow. Okay, so we're getting up to temp. I think I have this set to 300, but with the board on it and the thermal load, it's actually going to drop. So anyway, one thing I do want to mention is when you first put this board on, it's going to start smoking. It's not the board, it's actually the flux in the solder paste is going to start smoking. So you do kind of want some ventilation and not to directly breathe that in. Another thing, I'm working on a silicone mat, so heat resistant, and I have this like little metal dish that I have, you know, face down, just so I can put the board on afterwards and not thermally shock the board and let it cool down kind of slowly. Anyway, yeah, we're pretty much up to temp. So I'm going to just grab this and set this on here. You can already see some of the solder is reflown. I forgot a cap apparently. So I do have a cap right here. Just gonna push that on there. And it looks like it's going pretty well. I have the temperature actually a little higher than yesterday. And already on the time that I left it, got a little. Sometimes you'll need to help components on. I spent too much time trying to get that one component on. It gave it plenty of time to reflow itself. You might have to kind of give things a bit of a poke if it's slightly misaligned. But yeah, that looks pretty good to me. So I'm going to very carefully grab it, set it aside. Now there was a bit of an oopsie on the design. This switch, I designed the footprint for it because I couldn't find one in Eagle that would fit. And I messed up with the order of the pins, so I actually had it shorted. And when I'd soldered this board up, I could flash the bootloader, but when I hooked it up over USB, the chip wouldn't recognize the the CH340C enumerated, and it looked like I could program the chip, but it just would never respond. So what it ended up being was I had to cut off one each of the diagonal pins on this switch, and that allowed the switch to actually work, because otherwise it was as if the switch was permanently pressed because I miswired it. But I fixed the footprint in the Eagle layout, so it's all good now. So the version that I uploaded of this board is fully functional as is. Looks like the soldering went pretty well. There's 1, 2, 3, maybe 3 shorts on this side. None on this side. There's like 2 or 3 on this side. and a tiny, what looks like a solder ball. So what I'm going to end up doing is just reworking just those few pins that seem to have messed up. And this is cool enough to actually touch now. And one other thing I was interested in is, yeah, it started burning just slightly. You can see a little tiny bit of yellowing. That's the white solder mask kind of burns much easier than the other colors. It's much more noticeable. But I really like the black silk screening. It's a lot sharper than the white one. But anyway, looks like I'm going to actually have to fix some of these solder bridges with a wee bit of desoldering braid. So we'll pick there's like 3 of the pins at the very end that I've shorted together. There's just a little tiny bit too much solder paste on there, I guess. So my iron's set to 680 degrees Fahrenheit right now. I'm just going to kind of run the braid into that area and let it suck up just a little bit, just enough to clear the short there. And I'm going to do that all around the chip and then reflux it and then just run my iron over and reflow the solder. The whole point isn't to take out all of the solder because then you're going to leave a dry joint. It's just to clear the bridge, and that's it. And the last final step I like to do, actually pretty much anything that touched the solder paste is going to be pretty icky. What I like to do is use these alcohol wipes, and these are just wet wipes but coated in alcohol. And pretty much just wipe everything down. Sometimes a no clean flux, especially on white solder mask, I notice still leaves kind of brownish residue. Anyway, pretty much set on that. One very final thing to do is, before you plug this USB port in, we just soldered the pins on the back, so it's still floating, so you'll rip those off the first time you plug in the USB port if you also don't solder the 4 ground legs. So I'm going to do that really quick right now, because if I forget to do that, I just know I'm going to rip the pads off, and I'm going to have a very bad day if that happens. Okay, one very last thing. You may notice on certain components, there'll be little tiny beads of solder, usually almost microscopic, and I really should. I'm going to have to dig out the microscope and actually look at this underneath. But like right here, this resistor. Okay, this resistor here, there's a tiny little solder ball, and that's because there's just a little bit too much solder. It won't affect anything. You could actually probably leave that in, it won't harm anything. But if you notice anything similar, like between 2 pins on a chip, you definitely want to remove those. Even if it's not shorting anything, if it gets dislodged and falls and touches, you know, a power and ground pin on the chip, it could damage something. So it's actually best to remove them just right after visual inspection. Another thing is, might be a good idea actually to just throw this in the ultrasonic cleaner for a little while, just to clean off everything. There's some flux that's like in between pins of the chip that's really hard to reach. Probably won't do anything short term, but long term could cause a problem. And I'll get back to you guys when we're ready to burn the bootloader, plug this in, and get that going. Make sure that this actually works. Anyway, yeah, all in all, took me about, I would say, messing around and whatnot, it probably took me like 20-25 minutes to fully assemble this board and to get it working, which that's about half my time saved versus if I had to do it by hand. Especially the pin pitch on this TQFP is significantly more dense than the Atmega 328P, which is what I'm used to soldering. So anyway, yeah, that worked out great. Now I have a tiny little dev board I'm calling the MiniMega. Obviously play off of the Atmega. But yeah, anyway, if you guys are interested in building your own, design files will be up online. It's nothing special. It's not really optimized, but it is, you know, pretty compact board with a ton of I/O. So yeah, anyway, huge thanks to JLC PCB for sending me not only these boards, but the stencil as well. And also the MHP30 from Miniware definitely pulled its weight today. I 100% intend to try to assemble as much as possible going forward in the future using stencils and solder paste. It's just so much easier in general overall, and it'll give me the ability to solder packages, for instance, like BGA chips and whatnot, that you really can't solder with a conventional soldering iron. So anyway, yeah, hopefully you guys enjoyed this video, and I'll see you in the next one. Bye.